In this question, we need to find a and b, and then the first thing you'll notice is that there is a certain degree of ambiguity, and that's because we're not given the redemption value. We're given the par value, but then we're not given the redemption value. And the convention is that if we're not given the redemption value, we should treat the par value as a redemption value as well. And you'll find this convention in your SOA exams as well. So if you're not given the redemption value, but you're given the par value, then you should treat this as the redemption value as well. So in this case, we're going to treat 1 as a redemption value. That means when the bond matures, we're going to receive $1. So for this problem, we're going to use the premium discount formula. And then in this case, the redemption value is equal to 1, so this becomes this expression here. And then we're using this formula because the information that we're given is in the form of 1 plus something. And then we see that this formula also gives us an answer in the form of 1 plus something. So it's going to be much easier if we use the premium discount formula. So now for the first case that we're given, for the original coupon rate, we're given that the price of the bond is equal to 1 plus p. So that's equal to this, and you see that p is equal to g minus I times an. So this is the first piece of information that we gain from the question. And then, so let me just copy this out again. And then they do some modifications to the situation. So they keep the yield rate fixed, and then they have the coupon rate, and then the price would be equal to 1 plus q. So given this, we know that 1 plus q is going to be equal to 1 plus, so I don't know what g is, but we know that the coupon rate is half, so I'll just leave this blank for the time being. And then the yield rate is going to be fixed, and then of course this is also going to be fixed because the I here is also the yield rate. So we know that the coupon rate is half, so what is g going to be equal to? So recall that g is defined by this formula. So the face value times the coupon rate is equal to the redemption value times g. And if r is halved and then f and c is not changed, then g must also be halved. So in this case, this is going to be g over 2. So we know that q is equal to 1/2 g minus I an I. So this is the value of q. Now we move on to the third phase of the problem. Now we're told that the bond's coupon rate is doubled, and then we need to express our answer in this form, and then we need to find a and b. So now that the coupon rate is doubled, we know that the price of the bond is given by this expression. And then we're given that this is equal to 1 plus AP plus BQ. So you see that 2G minus I AN is equal to AP plus BQ. And then looking back at what we just obtained, we know that Q is equal to 1/2 G minus I AN, and then P is equal to G minus I AN. So all you have to do is just to substitute everything directly into this formula, and then you see that we group the G terms together. You get A plus 1/2 B times G, and then minus A plus B I AN. And then because both of these sides must be equal, you can match the coefficients to find A and B. So we know that the coefficient for G is equal to 2, so A plus 1/2 B must be equal to 2. And then A plus B, negative A plus B is equal to negative 1. So A plus B must also be equal to 1. So now we can just simply solve the simultaneous equation. We'll take the difference between these two. So we get 1/2 B is equal to negative 1. B is equal to negative 2. So this is part of our answer. And then if you substitute B equal to negative 2, you get A minus 1 is equal to 2. So A is equal to 3. So this is the second part of our answer. So this is our answer.